In every industrial plant where piping is used, safe and serviceable maintenance of valves and fittings is indispensable. The purpose of piping pointers is to make available to industrial maintenance men the practical information which Crane, the world's largest manufacturer of valves and fittings, has developed in its more than 88 years of experience. There are always young men starting to learn the essential jobs of industry. But in emergencies, it's sometimes necessary for a great many men to learn quickly how to assume responsibilities they've never faced before. Well, piping pointers is intended to help such men and to refresh the memories of others who may have forgotten some of the tricks of the trade due to infrequent use of them. In order to review these points as briefly and clearly as possible, we're going to use two methods of study, this textbook and actual demonstration, both here and on the job. Now, in every trade, certain words are used with special meaning, and it isn't always the meaning you'd expect. There are a good many special words and special uses of words that you'll need to understand before you can handle piping intelligently. So let's start making sure we all speak the same language. Brass and iron materials are commonly described as standard and extra heavy. These terms indicate their service limitations. Standard, for example, generally means suited for steam working pressures up to 125 pounds. Extra heavy means suited to steam working pressures up to 250 pounds. Steel materials, on the other hand, are usually referred to by pressure classifications such as 150 pound, 300 pound, 600 pound, and so on. Materials are also identified according to the types of end connections for which they are suited. Screwed end refers to valves and fittings having either threaded male ends or tapped female ends. These are not often used with pipe over 6 inches in diameter because of the extreme difficulty in making them up. Flanged end refers to valves and fittings which are designed to be attached to pipe or equipment with bolted connections. And welding end implies welding to the connecting pipe. This can be done either by butt welding or socket welding. The difference is in the ends to be welded. Butt welding fittings and valves have the ends beveled. Fittings designed for socket welding are shaped so as to slip over the pipe. In either case, the ends are fitted together and then welded in place. Another type of end connection, common to copper and brass fittings, is the solder joint end. Here, the socketed end of the fitting or valve is slipped over the pipe and solder is run in between them. Proper heating causes the solder to spread evenly in all directions inside the joint. Now, continuing with the language of piping, let's learn the special meaning of some more important words. Is this all that elbow means to you? Is T merely a letter of the alphabet or something your wife drinks? Does a cross mean a symbol of spiritual faith or the mark a free man makes in voting or something more? Well, all of these words and some others have their special meanings in pipe fitting. An elbow is a fitting that makes a 90-degree turn in a pipeline. For special purposes, elbows are also made in 60-degree, 45-degree, and 22.5-degree patterns. When you need a T in piping, it's a fitting shaped like a letter T, and it's used to take a right-angle line off a run of pipe. A cross is like a plus sign. It's used where interconnecting pipes intersect. And then there's the bushing, which is used to reduce the size of a fitting. It's helpful in emergencies where you can't get a regular reducing fitting. A plug is used for blanking off a line and is often a very important safety precaution. And a street L is like a regular L, except that it has a male thread on one end. You won't have any trouble remembering what a coupling is. It connects two lengths of pipe. A union does the same thing, with the advantage of providing entry into a line. Unions are important, as they permit easy assembly and dismantling of piping. Union fittings serve a similar purpose and save nipples as well. The flange union is used in the same way, mostly for low-pressure work. It usually requires a gasket to make a tight joint. Nipples are of three types. The close nipple, used where the distance between the connected parts is very small, has threads throughout its entire length. A short nipple has a small shoulder between the threads, and a long nipple is anything up to 12 inches in any size of pipe. Anything longer is called cut pipe. Pipe fittings are made of many different materials. And until you're familiar with them, it may not be easy to tell them apart. Cast iron and malleable iron fittings look very much alike, but the wider band around the cast iron makes it easy to distinguish from malleable iron. Although both types are recommended for the same services, many maintenance men have a preference for one or the other. Some like cast iron because it can easily be broken by a hammer blow when it's necessary to tear down a line. Others prefer malleable iron because it's tougher and can withstand shock and vibration strains better. You can identify forged steel by the mark FS or the words forged steel on the piece. And cast steel fittings, at least when they're new, usually have a coating of light gray or aluminum paint. Now, what about the different types of valves? The two commonest kinds are gate valves and globe valves. Gate valves get their name from the gate-like disc which moves across the path of flow. When wide open, they offer very little resistance to flow, since the seat openings are approximately the same size as the inside diameter of the pipe. Gate valves work best on wide open or completely closed surfaces. They should never be used for regulating flow, because the high velocity of flow past the disc when the valve is partly closed causes severe erosion or cutting of the faces. Gate valves are made in two general types, solid wedge and double disc. As with other items of piping materials, the maintenance man's choice is likely to depend on his personal preference. Generally speaking, however, the wedge disc type is best for most service requirements. Globe valves, the other common type, get their name from the globular shape of the valve body. In passing through a globe valve, the direction of flow is changed, and of course this means greater resistance to free movement. The design of globe valves, however, makes them ideal for even the severest service, the regulation of flow, sometimes called throttling. Another feature is that it's easier to regrind the seat and disc of a globe valve. Now, unlike gate valves, which come in any size, globe valves larger than 12 inches are seldom used because of the extreme difficulty in opening and closing them and in making them tight. Globe valve discs are made in a number of different types to meet many different service needs. The conventional type is sometimes made so that the seating surfaces are rounded like a ball or beveled like this one. The plug type is conically shaped, making it unusually good for the severest of services. In the composition type, the disc is generally of some non-metallic material. The wide variety of available compositions makes these valves suitable for many kinds of liquid and gas services. It should never be used for throttling, however, because the composition materials will not stand up in such service. There's one very important modification of the globe valve design which deserves more consideration than it gets. This is the angle valve. In basic design, angle valves are the same as globe valves, but the pipe openings are at right angles to each other. This makes the angle valve convenient where a turn is made in a line. Used in that way, it saves a nipple and an elbow, as well as installation time. Now, the various types of gate and globe valves serve to turn on flow or shut it off. But the traffic cops in pipelines are the check valves, so called because they prevent or check the reversal of flow. Now, check valves are made in two basic types, swing and lift. The swing check is much like the gate valve in design, for it permits straightway flow. Generally speaking, this is the type of check to use in the same line with gate valves. The lift check is much like a globe valve, for the direction of flow through the valve body is changed. To prevent backflow, the disc simply drops to its seat. This type is generally used in the same line with globe valves. There are many other types of valves, including pop safety valves, relief valves, pressure regulators, stop check valves, quick opening gate and globe valves, and cocks. Each of them meets definite needs. However, the average maintenance man's contact will be mainly with gate, globe, angle, and check valves. So our discussion centers mainly around these types. Now, valves, like other piping materials, have certain safety limits, expressed in their pressure and temperature ratings. Crane valves, for example, have symbols like these that tell the story. The marking 125S indicates 125 pounds steam pressure, and 200 WOG means 200 pounds water, oil, or gas at cold working pressures. By the way, if there's only one figure on the valve body, it indicates steam working pressure unless otherwise designated. High temperature reduces the safety factor, and cold working pressures are therefore usually higher than the steam pressure markings. Now, if you're uncertain about the marking on a valve, look in the maker's catalog. And if you don't have the exact maker's catalog, use any one that's handy. You see, working pressures and temperatures for various types of valves are pretty well standardized. Maximum working temperatures depend upon the material from which the valve is made. For instance, iron should not be used on temperatures above 500 degrees, or brass where temperatures exceed 550 degrees. Certain steel valves, working at no more than 100 degrees temperature, will handle pressures up to 6,000 pounds. But with a temperature of 1,100 degrees, the same valve is good for pressures only up to 1,175 pounds. If you have a proper understanding of the qualities of various kinds of valves and fittings, you'll realize the importance of handling them intelligently. Good handling of valves, fittings, and pipe requires thorough acquaintance with the tools of your trade. Let's begin with wrenches. The pipe wrench, a lot of people call it the Stilson wrench, is the most useful tool you will have. It's top-notch in the right place, but can do a lot of harm if it's wrongly used. One place not to use your pipe wrench is on a valve body. If you understand how it works, you will know why. With this type of wrench, the more you pull, the harder you squeeze. Applied to a valve body, its crushing effect may distort the piece and ruin it. Even when it's used in the right way, if your wrench is too large, it may damage or even break the material on which you're working. And of course, if your wrench is too small for the job, it won't do a satisfactory job either. You'll find the monkey wrench, with its smooth, square jaws, almost as important as the pipe wrench. The monkey wrench is the right thing to use on a valve. It fits better than a pipe wrench, and it can't cause damage by crushing. The strap wrench is useful when you're working with plated or highly polished pipes and fittings, or in close quarters. It isn't suitable for heavy work. Pipe tongues are used like wrenches, and although they're made for pipe from 1/8 inch diameter and up, they're mostly used for 4-inch and larger pipe because of the greater leverage they provide. You can't cut and thread pipe without using a vise. The pipe vise is used only for pipe, but the machinist's vise, especially if it's of the combination type, can be used for both pipe and other purposes. Useful as it is, the vise can be misused. If you lean on the handle too much, you can damage the valve body just as you can with a pipe wrench. Remember to use soft jaws of copper or lead before clamping a valve in a vise so as to prevent damaging the ends. In assembling a valve and nipple, put the nipple, not the valve, in the vise. Use your monkey wrench on the end of the valve nearest the nipple to avoid twisting the valve body. That isn't all. So far, in fact, we've left out one of the most important factors: proper cleaning. You've all seen pipes stored where dust will get into it, or maybe mud or sand. And, of course, other things can happen to it, too. What we call foreign matter, which means almost anything that we don't like, may get into the pipe. Well, what do you do about it? You can blow out or swab out this dirt or foreign matter. Such stuff invariably collects in a valve and may put it out of commission at the very start. Even if nothing gets inside, the threads may pick up a lot of dust, dirt, and grit, which can cause trouble when you're making anything as accurate as a threaded joint. Dirty threads increase friction and make it harder to make a tight connection. They may even cause tearing of the metal during screwing up. It's better to make sure that both the threads are clean and that a suitable lubricant is used before making up a joint. Now, another thing. You can't handle pipe carelessly and expect it to work satisfactorily. If you bang it against something hard, you'll damage it. If there's any chance of that, check up on it right away. When a male thread is slightly damaged or distorted, put a drift in the end to round it out, and then run a die over the thread to clean it up. If a female thread has been damaged, be sure that it's clean, and then, if necessary, run through a tap to correct the damage to the threads. Pipe may need to be reamed to remove bars left from cutting, particularly if cut with a rotary cutter. This should be done before threading. There's the special problem that arises when pipe is cut and threaded on the job. These operations may be properly performed, but it's always good practice to see that all chips are cleaned off before you try to make a joint. Screwed connections are the commonest kind of pipe connections. They're easy to make in the small sizes and can be properly made by almost anyone. Pipe threads are tapered, and certain standard dimensions have been established for their proper makeup in various sizes. This cross-section view shows the relation of the male and female parts in a properly made-up joint. In order to get a good, tight metal-to-metal joint, the first important thing is to see that the threads are clean. It's good practice to use a lubricant on the threads to reduce friction when the parts are screwed together. Put the lubricant only on the male thread so that any excess will be squeezed to the outside of the joint rather than into the pipeline. Lubricants, or pipe dope as they're commonly called, should not be expected to compensate for poor workmanship. Use the proper size wrench. Too large a wrench will provide too much leverage. And don't think that the joint must be tightened until all the exposed threads are concealed. If the threads are properly cut and pulled up to the right point, the taper of the pipe thread and fitting will ensure a tight metal-to-metal joint. Generally, flanged joints are made up with a gasket between the machined faces of the opposing flanges, which are then pulled together with bolts. It's important to support the pipe in such a way that the flange faces can be brought into perfect parallel alignment. In working on flanged material, always clean the faces first. Cleaning eliminates dirt and grit, which might cause damage. Put half of the bolts through the flanges to hold the gasket when it's dropped into place. For this work, a ring gasket is used rather than a full-face gasket, so the bolts do not go through it. Now put the other bolts in place. And when you pull them up, don't make the mistake of doing it in rotation around the pipe. Use the crossover method and tighten opposite pairs of bolts like this. 1, 2, 3, 4, 5, 6, 7, 8. This permits uniform loading of the bolts and proper centering, which avoids harmful stresses. Well, what we've considered so far might be called the elements of piping. Every maintenance man, as he carries on, realizes his need for more knowledge about piping materials, especially on how to install and care for valves. So let's discuss the subject of how to install a globe valve. You'll probably hear a good many arguments on whether such valves should be installed with the pressure above or below the disc. Therefore, a discussion of these few basic principles may help you determine what course you should follow. Where globe valves are to be used on hot surfaces, steam or otherwise, if the pressure is above the disc, the operating mechanism will be kept under temperature continuously. This makes for more efficient operation. If pressure on hot lines, particularly steam lines, is installed below the disc, the upper part of the valve will tend to cool. Cooling can cause enough contraction of the stem to lift the disc slightly, perhaps enough to cause a little leakage. The resulting extremely high velocity of flow may lead to severe erosion of the disc and seat. There's one kind of service in which a globe valve should always be installed with the pressure below the disc. This is where it's important to have flow continue, even if some accident should cause the disc to come off the stem. Boiler feed service is a typical example. But if safety considerations do not make it important for flow to continue, the valve will generally give better service and be more easily kept tight if it's installed with the pressure above the disc. After valves have been in service for some time, they may require either of two servicing operations: repacking of the stuffing box or general repairing of the working parts. If leakage occurs at the stuffing box shortly after installation, it can be stopped by simply pulling down on the stuffing box nut. However, if the leak occurs after long service, it may be necessary to repack the valve. This can often be done without removing the valve from the line. Use a packing hook to get out all of the old packing. Manufacturers generally use a ring packing. However, some plants prefer to use different types of packing for replacement. Then polish the valve stem with a strip of very fine emery cloth to remove the little bits of packing and slight scratches that may be present. Wipe the stem and inside of the stuffing box. Then put in a few rings of packing. Use the gland as a tamping tool to tamp it into the stuffing box. Continue to add packing until the box is filled. If the stuffing box flange is of the 2-bolt type, be careful to pull the bolts up evenly. This will avoid the risk of cocking the gland at an angle, which would cause binding of the stem. If a valve continues to leak at the seat, remove the bonnet and clean and examine the disc and body thoroughly. In new installations, the trouble may be due to dirt or pipe scale. If the disc and body rings are very badly damaged, repairs may not be practical. In some cases, the body seat rings may have to be replaced, while the disc can still be saved. For a thorough job, remove the stem from the bonnet and examine it for scoring and pitting. Put the stem in a soft-jawed vise for polishing with fine emery cloth. When the stem is polished, of course, you'll want to repack the stuffing box before reassembling the valve. See that the valve bonnet and other parts are cleaned of dirt, scale, and corrosion, which might damage the valve seats. And remember that it doesn't pay to try to salvage most gaskets. It's much better to use a new one. To remove cuts from the disc, set it in a vise with the face leveled. Then, with a piece of fine emery cloth wrapped around a flat tool, lap the entire bearing surface. Remove as little metal as possible in getting the required finish. Then turn the disc over and perform the same operation on the other side. Remember that this is not a simple job. If the body rings are not so badly damaged that they must be replaced, remove their cuts and scratches also by lapping. Use an emery block small enough to permit convenient rubbing of the ring all around. Work carefully and watch closely. Avoid removing too much metal, which would cause the disc to seat too low. When the seating surfaces, disc and body rings, are properly lapped, apply Prussian blue to the finished faces of the disc and insert it in the body. Then remove the disc and inspect it. If the Prussian blue is rubbed away excessively from any part of the disc, it means that the seating surfaces do not make continuous contact. Where Prussian blue can be seen on the body rings, it indicates the places where further lapping is needed. When the high spots have been rubbed down a little, wipe the body rings and the disc clean, apply a fresh, light coat of Prussian blue, and repeat the test. It may be necessary to check and correct the job several times before good continuous contact is indicated. In reassembling the valve, first insert the stem in the bonnet. With the disc on the stem, place the assembly in the body. Raise the disc to prevent contact with the seats and to permit seating the bonnet properly on the body before tightening the joint. Before you install the valve, be sure to test it for tightness. If all these precautions are observed, the repaired gate valve will be good for long, continued service. Repairs on metal-to-metal seat, globe, and angle valves can usually be made without removing them from the line. With this feature, there's no excuse for delaying repair of a leaking valve, especially since neglect invites serious damage. To start this job, remove the stem from the bonnet and place the disc in the vise using soft jaws to avoid possible damage. Unscrew the disc stem ring, lift out the stem, and insert a slug or coin inside the disc. Then replace the stem and tighten the ring to lock the disc to the stem. Now put a little emery-based grinding compound on the disc. But remember that too much grinding compound is likely to remove too much metal. Put the body and the bonnet together and turn the bonnet ring on loosely by hand to provide a guide for the stem. Grasp the hand wheel firmly and oscillate it back and forth. Inspect the work before you think it's completed, so as to avoid the risk of grinding more than is necessary. If the bearing is not yet smooth, replace the bonnet and continue the operation. When the grinding is completed, wipe the disc thoroughly. It should show a continuous smooth bearing on the seating surfaces when tested with Prussian blue. See that the seat and body are clean of all grinding compound and dirt, too. Then, before reassembling the valve, be sure to remove the slug from the disc so as to allow it to swivel freely on the stem. There's one advantage in using a coin instead of a slug for this purpose. It's easier to remember to take it out. This simple procedure makes it possible to keep globe and angle valves in good operating condition all the time. Where composition disc valves are used, it's an easy matter to replace the worn disc with a new one. Be sure to examine the seat in the valve to see that it's not damaged, for it may be necessary to remove cuts from it. In plants where many valves of this kind are used, it will save time if a number of extra disc holders are kept on hand, ready to install. Then, worn discs can be replaced whenever it's convenient. Now, no matter how much you've learned, it won't do you any good unless you use it. If you learn good shop practices and make them your habits, you'll surely make good on the job. But you'll find sometimes that all the things you'd like to have to work with aren't available. No book and no course of instruction can give you all the piping pointers there are. The best answer to some of your problems lies in your own ingenuity and resourcefulness. Now, if you'll each take a copy of this booklet, study it, and keep it handy, you'll find it mighty useful in your work.
Thank you, sir.
It covers all the points that we've reviewed today and quite a lot of other useful piping pointers that we didn't have time to discuss. Any of them may be useful. Perhaps all of them will be, in helping you lick the problems that turn up every day on your job. That is the friendly wish of Crane, the world's largest manufacturer of valves.